Another common application of systems of two equations are problems involving distance, rate, and time, and things flying into the wind or with the wind, or boats going with the current or against the current sort of thing. Our example here says a DC-10 is flying 3,000 kilometers in 3 hours with a tailwind and in 4 hours with the headwind. We want to find the speed of the plane and the speed of the wind and the speed of the plane in still air. So we have to remember this common formula, the DIRT formula as I call it, distance equals rate times time. We also have to have a little bit of common knowledge here that says if I've got a tailwind that's going with me, that's going to increase the actual speed of the plane. So one thing registers on the speedometer, but another thing is actually happening, the actual effective rate. If I'm flying with a headwind or against the wind, that's going to decrease or slow down, take away from my plane speed. Okay, so now two things we're supposed to find is plane speed, so I'm going to call that P, and wind speed W. All right, so those are going to be the two variables. Now what we know is that we're going with the tailwind and we're going with the headwind, two scenarios. The first, with a tailwind, we've got a distance of 3,000 kilometers. Now what about our rate? Well, it's the plane, whatever it says it's doing, and it's going with the wind, so we need to add the wind. So this whole thing, P plus W, times the time, is at 3 hours. Now with the headwind, we're still going 3,000 kilometers, but this time my rate here, notice I'm going to take my plane and subtract the wind speed because it needs to slow me down. And that means it's going to be more time, it's going to be 4 hours. Now here's a little trick I like to use. Instead of distributing at this point and then having to solve, I'm like, can't I divide the left and the right side by the same number? Of course I can. I divide both sides by 3,000 for the top one and get 1,000 equals P plus W. For the bottom equation, I'm going to divide both sides through by 4 and get 750 equals P minus W. Now this is very easy to solve either by substitution or addition elimination. Adding, I would get the 2p here and I get 1750. So dividing, I get my answers of 875 kilometers per hour for the plane. Putting that back into this equation over here, I would get the wind is 125 kilometers per hour.